Hey everybody, I was doing some debug this weekend and working with Code Interpreter on the free ham radio practice exams for license tests. And I realized that Code Interpreter will write code itself given the chance. And so I put that to work doing some debug yesterday. And so here's what's going on. I've shown you maps of the radio contacts from San Francisco to other places before. This one is out to Virginia. And I've talked about these legends, and this gives a good visual representation of what's going on, but it's hard to get a good feel for the numbers that are involved. And so what I've done, in addition to having these cesium graphs, which are really cool to look at, is I have set up a numeric graphing program where I can just say, you know what, go ahead and just give me the critical frequency at each point along the path. And you can see that the Glowtech data has 5-degree increments in longitude, and it has 2.5-degree increments in latitude. And so what I had the code doing was snapping to a square and then ignoring, so what I do is I get the great circle arc from one station to another, grab 100 points along that arc, and then I look at a point, the first point, see if it snap it to a square, and then I ignore all the points until we hit a new square, and then we snap to that square and get data. And so what you should expect to see is a data point per square. And so you can see this path going along goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. But if you look here, we've got 5 data points. And so it's really obvious this data in here is missing. And so for the fun of it, I put ChatGPT to work on it. And so I'm going to scroll up. My initial thought was I use a dataset database here. In Cesium, I can just give the Cesium viewer access to my local host, and it can pull out CZML data, for example. So first idea I had was, well, why don't I just ask GPT-5 if it can see my local host? Because web pages can. And it's, it said, nope, not this one, not this web page. It says, okay, cool. But it said what you can do is if you're trying to feed me data, you could just upload it. And so the data for the FOF2, the Glowtech data, is actually for the entire globe. And it gets a little bit hefty. But sure enough, I was able to upload the data. And then there was the RM2 cans data, so in other words, the radio contact data. And I uploaded it, and I said, you know what, tell me some things about the data. You should be able to work with it. And lo and behold, it dumped out tables of the data. And so, okay, cool. We know we can work with the data. In my code, which is written in Python, I use an SQL query like this. And what it does is it says for a given timestamp, pull out the maximum height of the F2 layer and do some calculations on the maximum electron density and get us a critical frequency. And that's the frequency radio wave. That's the highest frequency radio wave that can propagate straight up and reflect off the ionosphere straight back down. And so the spires you see are maximum height of the ionosphere. The colored squares represent critical frequency, and that's why you can see it over here. That's 4.409 megahertz or 90 kilohertz. Cool. So, and sure enough, it wrote some code and it dumped out the results. So now I know it can work. Great. And so now I want to know why this graph is broken. And so if you look, we're here at 224.40. And I say, hey, I want to pull out, and I know that Glowtech data comes every 5 minutes, every 10 minutes on the 5. And so I knew the closest Glowtech data would be at 225. And so I said, you know what, go ahead and pull out the data just for that query. Let's make sure you can do that. Did it. Then the next thing I wanted, so we're missing points here, right? And so I thought maybe I'm not calculating the 100 steps along here correctly. Maybe I'm not collapsing the cells correctly. And so I took the Python code, and rather than handing it all the Python code, I just said, hey, here's a method. Go ahead and run this method and let me know what output you get. it wrote up code to surround the method. It identified the fact, and we're going to get to that in a little bit, that I hadn't given it all of the code. It was actually filling in some of the code. And then I asked, can you plot that on a map in North America? No, it can't, but it can plot it on a longitude and latitude map. And if I blew this up, you would actually see all the points there. So the 100 points are getting, they're uniform, 100 points are getting made. Great. Next thing is, maybe my code isn't like snapping across cells the way I want it to. So in other words, when I tell it to cancel all these cells, maybe it's canceling something else as well. And so I said, okay, so what we're going to do next is we're going to run collapse points, collapse cells, and we're going to see all the points go across. And nope, there's still plenty of points going across. This looks a little odd, but right now I just wanted to know, was I collapsing cells correctly? And I was. Realized I had not given it some of the code yet, and it had actually filled in the code, did the way it thought it should be written. Spoiler, this is going to be where the bug is. And so I gave it that code, I said draw it again. And again, the collapse cells look a little bit more strange, but they're on the path. They're fairly regular on the path. So it seems good. And so I said, okay, well, cool. Now that we know where the cells should be, go ahead and take that data and access the database and grab out the height of the ionosphere and critical frequency at each point. And this is where things got interesting. And that table will be right here if we expand this out a little bit. Boop. And you can see that, I hope you can see, you can. There's no data. And I already had a bug running that sometimes the first point on the plot didn't get data here, which should have been over here. And lo and behold, there's no data in the first point at the transmit location. Then we get 3 sets of data, and then we're missing rows again. And then we get some more data. And so I asked it why it thought that was happening, and it went off. This took several minutes. I was actually already on a bus headed out from the house, checked in on this on the cell phone, and found out that it was trying to snap to cells that didn't exist. So each of these cells is at a particular location, separated by 2.5 degrees. And so if you tell it to go to a cell 1 degree over and make a query in the database, you get no data. And so that was it. That was the whole problem. And it exactly was the method that I told you it was. And so on the cell phone, I was able to change that method so that it was set for 2.5 degrees instead of 1.5 degrees. Told it to try again. I don't think this is it, but we will find out in a second. Maybe it is. Yep. Nope. Okay. We're still working through. There we go. So then the debug I did was to say, well, let's make sure, dump out the latitudes where there is data from GlowTech, and that's what this is. And I said, okay, cool. In that case, let's dump out the lats from the method that had a 1.5. They didn't match up. That's why the data wasn't there. And I said, okay, great. Change that 1.5 to 2.5 and try again. This time, if we look at, and it added this in for free. This is really cool. So it says, okay, here is what you're getting now. You're getting, that's the latitude in. This is what we're getting out. And did it change from the previous? Previous is nothing. Yes, it did. We're cranking along, and what we're doing is we're moving along that grid square. And I didn't tell it to put these trues and falses in here. And so 88.75, we're going to get there. I'm sure of it. And here we go. So we have 88.75, 88.75, and then here's 86.25, and it says it did change. And this way you can see it, you can do some math in your head, and you can see that it's syncing correctly to the next square. So that was really cool. And the true-false on a larger screen, I was able to just scan through and see that we now had a method that worked. And so I said, okay, cool. Let's go ahead and run with 2.5 again, and let's look at the output data. And when we did, lo and behold, there are all the points. So we went from this completely missing set of points here to there's that step down, 1, 2, 3, 4. And then all of this detail in here we now have again. And so overall, it was a really pleasant debugging experience. I could do it on the bus on my way to do something else on a Sunday. And it actually found out what my problem was. And so it could access databases that I uploaded to it. It could take code fragments I gave it and run it. A little bit spookily, if I didn't give it all the code, it just put in code that it thought looked good. So that was a little odd. And this is just me double checking yet another path. And it helped me find the problem, and it's all debugged and fixed now. So anyway, just wanted to run you through what I did with GPT-5, both with data analysis and how that was really handy for code debug this weekend. Have a good afternoon, everybody.